Yeah. So, hi, hello, welcome to DurgaSoft online training sessions. Myself, K. Prakash Babu, having almost 16 years of experience as a trainer, sir. Okay. So, I trained different programming languages in various engineering colleges, and I worked as a technical trainer, department HOD as a CRT. Now, just I'm working for DurgaSoft from the past 4 years. I'm taking the classes in online mode. That's all about myself. Soon you will get complete information. Right. Sir, first of all, before starting this course, compulsory prerequisite must be required, sir. Prerequisite. Uh, can anyone tell me, you know the course, right? What is the title of the courses, friends? Please confirm. Hmm. In
DSA
this
with
course,
Java.
yes, data structures and algorithms, data structures and algorithms by using which programming language? By using which programming language?
Java.
Java. So it is also called as DSA with Java. Here, prerequisite for this compulsory, you should have a knowledge in CoreJava. Otherwise, this course will become very difficult for you to understand because here I'm not explaining the Java programming language. We are going to see so many algorithms and the data structures. So if you are seeing any problem statement, sir, addition of two numbers, 2 and 3 are the inputs. Our expected output is 5. For this, we have to write a code. We need to analyze this problem statement and we have to write the instructions which can be understandable by the machine. And there is a process. You have to follow some rules and regulations, syntaxes and semantics. And once if you click OK button or if you execute the program, you are going to get output like 5. For that, we have to write a program. And in this case also, we are going to see some problem statements and we are going to write code for that. For writing the code, we are using Java. That is nothing but here main intention. That's why the title of the course is nothing but what? Data structures and algorithms with Java. So prerequisite for this course is nothing but what? Compulsory. You should have a knowledge in core Java. Otherwise, this course is not recommended. What topics we are going to cover? Sir, before that, just I want to give only two things. What is the duration of this particular course? Sir, generally for my classes, I won't prefer any duration, but maximum I'm going to take 2 months. Within 2 months, I'm going to complete the syllabus. This total syllabus I'm going to complete in 2 months. And my sincere request is please ready to attend even on weekends also. Weekends also. Compulsory you have to attend on weekends also. Sir, not every weekend. Occasionally, we are going to plan 1 week before itself. I am going to announce. Sir, these demo classes will be there only for 4 days. That is today, tomorrow, day after tomorrow, and up to Thursday, you are going to have the demo sessions. From Friday, we will have our regular classes. This week, Friday, Saturday, we have class at the same time. This Sunday, I am going to plan a class. So from 7 to 9:30, where I'm going to cover string data structure with 50 programs. It is mandatory to attend this session also. So like that, there are some easy topics will be there, which I'm going to take on weekends. Okay. So this is nothing but duration what we have. Coming to the timings, sir, there is one small information related to these timings. Actually, we started a new batch in the last week itself. Last week itself, we started a new batch, 7:30 p.m. So for that, this batch is nothing but add-on batch. I'm going to combine this batch with that batch. The timings of the session is nothing but 7:30 p.m. 7:30 p.m. to 8:30 p.m. Every day, 1 hour session will be there, Monday to Friday. So Saturday and Sunday, maximum sessions won't be there, but alternatively, we will plan some sessions on that. Easy topics, doubts clarification sessions, these things will be there. Sir, if you are okay with everything, if you are having any queries, you can feel free to ask. Then I will start our regular class. Sir, everything is clear? Right. So coming to the syllabus, sir, what are the topics that we are going to cover here? Coming to the course syllabus, we are going to see introduction to data structures. Sir, what is mean by data structures? What things will be there in the data structure? Okay, like a stack, a queue, tree, everything. What structure they are going to follow? What are the operations that we can able to perform on that? Like in detail information about the data structures, we are going to cover. After that, we will see introduction to algorithms also. Like what is mean by algorithm? How we can able to write algorithm? Sir, I have search algorithms are there. I want to implement a sort algorithms. I want to implement greedy algorithms. Like how you can able to implement the algorithms. Next and after that, we are going to see time and space complexities. This is very, very important. Okay, time and space complexities. How you are going to use the notations like big O notation, theta notation, okay, omega notation, how we are using, what is mean by worst case complexity, best case complexity, average case complexity, like in detail we are going to discuss. After that, even we are going to talk about array data structure. From the language, there will be one inbuilt data structure will be there. Okay. So that 1 second, sir, please be on mute and please listen whatever I'm speaking. After that, you can ask all your queries. Okay, because please wait. I will address your questions. Please wait. So array data structure we are going to cover, like what is mean by array, how to create memory representations, so syntactical things, exceptions, everything we are going to see. And even this on arrays, we are going to cover some top level problems also. Okay. Next and after that, string data structure. I told right. So this week we are going to finish this. So string data structure, our string objects are mutable as well as immutable. So here we have some 4 types of strings are there, like a string, string buffer, string builder, string tokenizer. But the advantage of string is nothing but some objects are mutable, some objects are immutable. That's why there will be a special memory location is there, like string constant pool. So when we are going for string constant pool, when an object will be created in string constant pool, when an object will be created in heap memory location, that in detail information we are going to cover under this string. Sir, here I'm going to cover even some 50 programs also by covering each and every method. After that, we are going to start recursion. I can say recursive algorithms. Recursion means, I think you know, a method or a function which is called by itself is called as recursion. How we are going to implement this recursion? Around some 15 to 20 problems we are going to see on this recursion. Sir, maybe tomorrow or today itself I am going to start this chapter for you people. What is mean by recursion, how you can implement. On the continuation of this recursion, we have backtracking is there. Backtracking means, so we can search for some result. Sir, I am searching for some result. If the result is unable to get, or I didn't find the result, you can go back. You can go back and search for the data in some other path. Okay, that is called as backtracking. We are going to see how we can implement backtracking. So in our Java, by using Java, how to implement backtracking algorithms, we are going to see in detail. Okay, for that, some algorithms must be followed. Of course, it is one of the application of recursion only. Next, we have some divide and conquer. Okay, divide and conquer algorithms are there. Best example, sir, binary search, it is going to follow divide and conquer. Even quicksort, it is going to follow divide and conquer. Merge sort, it is going to follow divide and conquer. Almost all three applications are going to follow divide and conquer. How that divide and conquer is going to work, we are going to see. It is also type of algorithm. Then dynamic programming. Dynamic programming algorithms, or I can say applications. So DP problems, dynamic programming. Okay, how we can implement this dynamic programming? So what kind of different approaches are there? How we are going to reduce the number of method calls? So the main intention for dynamic programming is nothing but to reduce the method calls. So there are different kinds of algorithms will be there. We are going to see that. Next and after that, greedy algorithms also we are going to see. What is mean by greedy algorithm? How you can able to get a maximum profit, a minimum profit. So coin problems, everything we are going to discuss. After that, sorting. Sorting algorithms will be there, and searching algorithms also we are going to cover. Okay, around 5 to 6 sorting algorithms we are going to see. Then there is one concept is there like hashing, or even it is called as a hash table. How you can implement that. And very important topic, linked list data structure. Sir, maybe this topic is also I'm going to cover on weekend. By 2 days, 3 plus 3, 6 hours we are going to spend on linked list. We have single linked list is there, double linked list, circular single linked list, circular double linked list. Like this, we are going to cover. Next and after that, stack data structure. So how you can implement a stack data structure? So what are the various tools are there? And even some applications also we are going to discuss. Next and after that, queue data structure, how to create our own queue, how you can implement. And next and after that, tree data structure. Minimum some 20 operations we are going to see on tree data structure. All our applications only. Next, there are different types of trees are there, sir. One is nothing but a binary tree is there. Next and after that, a binary search tree is there. So next and after that, AVL tree, height balanced trees, these and all. So we are going to see. Next and after that, heap data structure. Heap data structure, which is also called as a priority queue. Priority queue. So next we are going to talk about graph data structure. These are nothing but the topics which we are going to cover as a part of our DSA course. This total syllabus is going to be completed in 2 months. The topics which is going to take much time is nothing but string data structure. Next and after that, linked list data structure. Next and after that, tree data structure and graph. So this string data structure and linked list data structure I'm going to cover on weekends. And one more weekend I'm going to take for AVL tree and for graph. Total, in our total 2 months course, we are going to take maybe 3 or 4 weekends. Okay. So in the beginning itself, I'm giving, sir, that conclusion. This is nothing but the topics which we are going to cover in our total course. Now, if you are having any queries on syllabus, you can feel free to ask. So first, I will clarify some of the doubts which I got in chat window. Later, we will go for remaining. Yeah, you can unmute and you can ask if any questions are there. If everything is okay, just acknowledge me. Someone is asking, sir, can you please elaborate more on what topics we exactly need to learn in CoreJava before starting DSA? Sir, if you have CoreJava knowledge, it is sufficient. In that specific topics, how I can give? Because you need to understand how to write the program, how to construct a loop, how to write the condition. Anyway, arrays and all I am going to explain. So even how to create an object, how to write a method, these are small basic concepts only, not in depth. Next, recordings will be available even after course ended or any other class missed. Yeah, if you miss any class, you can watch the video. And even I'm instructing for my all students, whenever a class got completed, you need to maintain a separate notebook for this. practice notebook. Once if the class got completed, what you have to do is, so on the same day or next day, they will upload the video. You have to watch that video one more time. That is highly recommended. And whatever example I have taken, try to change the values or try to change the diagram. So try to take different entities and try by your own. If it is working, just close the book, enjoy for 10 or 15 minutes, take another example and try. For every topic, if I am taking one example, if you practice the same thing by taking 2 or 3 examples, tomorrow if they have given any problem related to that, without understanding, I mean, without seeing any book or code, you can able to write the algorithm. So when it is possible, if you follow each and every class regularly, simply putting the mobile and registering for the course and keeping the mobile and going for some work is not recommended. You have to sit with me along with me for this 1 hour. Then only you can understand. Okay. Right. Sir, any doubt? Please confirm. Recording sessions will be available for 6 months. 6 months access. Yeah. Any queries? Please feel free to ask. Will you provide assignments, practice questions? Definitely. Definitely. We are going to give assignments and coding challenges. Some links I will give. From that you have to practice. Yes, any other? Yes, please confirm. Any other doubts? Practical applications of these will be explained. Maybe 1 or 2. Okay, but not in depth, because understanding data structure itself is a difficult job. Once if you understand, easily you can implement. Okay. Ayo, no doubts, sir. Can I continue?
Yes.
Right. Sir, in these demo sessions, I don't want to take any random applications or any other thing. I don't want to impress yours. So just directly I'm starting one topic, which is nothing but recursive algorithms for a couple of weeks or maybe 1 week completely. So up to next week middle, we are going to see recursive algorithms. Okay. I will start directly the topic. Right. Recursion. Yeah. Can anyone tell me what is mean by this recursion? Please confirm. What is mean by this recursion? Anyone? General meaning. Feel free to interact. Good. A method calling itself. Very good. See, I have a simple Java program is there. I have a simple Java program is there. Like assume the Java program title is nothing but something like a test. So I'm going to define a method here. I'm going to define a method here. What is that method is? Let me define a separate class for doing that. So there is a class with name demo and I'm defining one method m. Inside this method, friends, I'm trying to print some message. Like what is the message that I'm taking here is, okay, so sample method, like this I'm taking sample method. Sir, once if you run this Java program, I hope you know how to compile and execute your Java programs. There are some basic commands are there, like javac test.java. This command is used to compile your Java program. So generally, I will give the file name as a test. That's why directly I'm compiling. And you can run the Java program by taking Java space test. If you run, what will happen? Sir, nothing is printed here. Why nothing is printed? Because we have not written any code. Sir, if I want to execute this method, what we have to do? We have to do 2 steps. Can you please tell me what is the first step? Please unmute and please speak. Then only we can have an interaction. Please confirm what is the first step.
We have to create a one object of demo and
Very good.
then object dot method name.
Yes, that's all. So first step is we have to create object for that demo class. How to create object? What is the class name? Demo. Object name, any name you can take here, is equal to new operator, and I am taking object class name. Something like it is a constructor. Because of this line, what will happen? A new object will be created for which method? M method. By using that object, I am calling the method, sir. So what output we are expecting for this? It will execute sample method. This is nothing but a simple Java program what we have. Of course, I have not started recursion yet. Just a simple example I demonstrated. Sir, if you are clear with this example, there are some internal things we need to understand from this example. I will demonstrate that with the help of one diagram, sir. Clear up to this, everyone? Clear, friends? Please confirm.
Yes. Yes.
Now, sir, what will happen? Now my question is, can you please tell me, this is my method M, right? Who called this method, sir? Who called this method?
Test class.
No. Test class
Compiler.
never
Compiler.
calls. No. There is one method. Method is going to call this method. Which method called that one?
Main method.
Main. So internally, recursion is going to use one special data structure, sir. What is that data structure? Stack data structure they are going to maintain. If you don't know about the stack, just ignore. Stack is nothing but a box like this. Best example, sir, if you are putting books in your shelf, you are going to follow stack data structure. First book on the top of that second book, on the top of that third book. Like that, if you keep 5 books, what will happen? Which book you kept at the top, you are going to take that book for the usage. Sir, ladies are wearing bangles. So suppose assume they wear 3 bangles. Which bangle they inserted at last? They have to remove that bangle only. This is the data structure which is followed internally in stack. So in technical terms, I can use LIFO. So what is the meaning of LIFO? Last in. Whatever object that you inserted last into the stack, last in, first out. You have to remove first. Sir, first, Java virtual machine. There will be a separate person. Okay. So what is that person here? So Java virtual machine will be there. So this Java virtual machine, what they are going to do here is, okay. So 1 second, friends. Right. So now you can see, so there is one person. What is the name of the person is, I'm taking this person name as JVM, sir, Java Virtual Machine. So first this Java Virtual Machine is going to trigger which method? Main method. So the first method call will be main. That entry will be stored inside stack. Then main is going to call some other method. What is that method? From here, the control will go here. And what is a message here? We have that message, it will execute. So that's all. That entry also will be there in the stack. That's all. Is M is calling any other method? No. That's why what will happen? Simply it is going to store entries like this. One more point. After this sample method execution completed, then what will happen? It will come to the next caller. Sir, M method completed. It will delete this entry. Again, it will come back to the main. This each and every entry is called as a stack frame. It will come to the next method call. Sir, who called this M? Main. Is there any pending instructions in the main? No, sir. Simply it will terminate. Like that, These entries will be stored inside stack, and after calling each and every method, it is going to terminate in this style. Sir, if you are clear with this, I am going to write another instruction. You have to tell answer for that. Sir, clear up to this?
Yeah.
Now, so what is my question is, now I am going to take one more instruction here. What is that instruction? He is, sir, I am taking demo class main method. Okay. And here I'm going to take, so system dot out dot println of, so test class main method. So I'm taking here demo class m method. Can you please confirm in which order it will display? First test class main method or demo class m method? Which one?
Demo class
Demo
and
class
method.
main method. M method.
Demo class m method. Sir, how you are telling? Based on the diagram or main method is going to execute first?
Main method calling.
Main method first execute.
Demo method.
Please make sure first we are going to see the stack diagram. You can understand now. Whatever flow I explained, if you correlate, you can understand. Listen carefully. What is the first step? Sir, we created first main method is going to start execution. Corresponding entry will be there here. Okay, fine. Then what will happen? We created one object. By using that object, we are calling m. So main method is calling some other method called m. This is the immediate instruction what we have. So control will go here and it will execute this instruction. So what is the output that we are going to get? Demo class m method will come. So after that, the control will come back. So it will delete the instruction and it will come back. Then main method is there. So is there any pending instructions? Yes. So that pending instruction will be executed. This is nothing but the order what we are going to get. After that, it will also delete this and terminate the program. Let us compile and execute. Is my expected output is the same? Yes. Demo class m method, test class main method, like that we are getting. Sir, hope everyone understood. So how this output we are going to get. I'm trying to explain how internally method calls will be there. So inside Java, whenever you are calling the methods, how internally it is going to store. Sir, everyone feeling comfortable up to this so that I can go for next level. Clear, friends? Please confirm.
Yes.
Yes.
Right. Now, sir, you have to tell the output for this program. So what I am doing is, sir, here I am going to take system.out.println, system.out.println, main method started. Okay. And here I am taking system.out.println. So main method ended. Like this I am taking for your easy understanding purpose. Assume this is nothing but okay. So you have to tell output. No need for all these things. And tell me, sir, what is output for this program?
Main method
Main
started,
method
demo class m method. Main method.
Main method started. Then we are calling a method demo class m method. Then main method ended. Right, sir?
Yes.
Now you can see the output what we expected is the same thing. So main method started, demo class m method, main method ended. Now what I am doing is I am giving the method name as m1. Sir, listen carefully. M1 method started. M1 method started. And then I am printing M1 method ended. Now tell me what is output. You can tell.
Main method started. M1 method
Main
started.
method started.
M2 method started.
Very good. So main method started. M1 method started. M2 method ended. Sorry, M1 method
Started.
so
Yeah.
ended. Okay. And then main method ended. In the same order only we will get, right? Let me check. Main method started. M1 method started. M1 method ended. Main method ended. Sir, if you are clear with this, next step I am going to explain. Yeah, Kasi Vishwanath, please wait. How LIFO is applied, I will demonstrate. Sir, clear? Can I go for next complex?
Yeah.
Sir, next level, please listen carefully. The total story why I am explaining is, don't feel that it is very simple concept. So n number of things are there inside this. That's why I am demonstrating with multiple examples. Please listen carefully. See, inside this M1, I am calling some other method M2. So what is this M2 method is, sir, M2 method I am defining, M2 method started, M2 method ended. Now listen carefully. If you follow this diagram, you can understand what is the output. Sir, first what will happen? A stack is going to be created. Sir, tell me, sir, what is the first entry, sir? What is the
Main
first
method.
entry?
Main method.
No. I'm talking about the entry in the stack. First,
Main.
it is going to
First
call
main
which
method.
method? Main method.
Main
So
method.
main method will do its job. Can I say this is my first output, right? First line.
Yes.
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 Then it is redirecting to M1. So it is internally calling which method?
M1.
M1 method.
M1.
So the control will go to the M1. In M1, can I say this is the second line of output what we are going to get? Am I right?
Yes.
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 Then what will happen? It is calling
M2.
another method. Sir, can I say another entry will be there here, right?
Yes.
So what will happen? The control will go to M2 and it will print this line. This is the third line what we have. Sir, are you clear with these three lines?
Yes.
Yes.
Now, so one person asked, sir, how it is LIFO principle? Main is calling someone. This someone is calling some other person. Now this person is not calling any other method. With this, the program is going to be stopped. But which method is latestly called M2? Is there any pending instruction in M2? Can you please tell me, sir?
Yes. M2
Is
method
that,
ended.
yes,
And
that
to the
pending instruction, it will execute immediately. Sir, which method it is executing? Last inserted method. Then corresponding entry will be deleted from the stack and it will come back to the next latest method. What is the next latest method?
M1.
M1. Is there any pending instructions in M1?
Yes.
Yes.
M1 method
Yes.
ended.
So that method is going to be executed. This is the fifth line what we are going to get. So that's all. Then again it will come to main. Is there any pending instructions in main? Yes, right. This
Yes.
will
Yeah.
become sixth line. Like this, in which order you stored, you make a call to these methods, in that order it will execute. Sir, do you know, after this method call, if you are taking any statement, this is called as backtracking. Anyway, we will see in detail about this. This principle is called as what? Backtracking. And it is a beautiful recursion concept what we have. We are going to see multiple examples on this. Sir, are you clear with this approach?
Yes.
Now, sir, I want to test. Really, is it working or not? We need to check. Sir, now you can see main method started. From that M1 method we called. It is also started. From that M2 method we called. Sir, it is also started. Then we called M2 method. M2 pending instructions. Then M1 pending instructions. Then main method pending instructions. Sir, I hope everyone got clarity with this example also. I am not going much examples. This is sufficient. Clear up to this?
Yes.
Now, with one last example, I will go to the main concept. Sir, some people may have a doubt. What is their doubt is, sir, you are telling this stack and all. So just you are representing with visualization. Where is the proof? Where is the proof for that? Like that, you may have a question. For that, what I will do is, so please listen carefully. We are calling M1 method. We are calling M1 method. That M1 method is calling, okay, M2 method. That M2 method is again calling M3 method. Listen carefully. From that M3 method, we are not doing any activity. Just to simplify my code, I am taking like this. So in M3 method, I'm taking one message like system.out.println of. So I'm taking 10 by 2. Sir, first, what is a stack entry for these? First, a stack will be created. First, a stack will be created like this. What is the first entry? Main method. From main, we called M1. From M1, we called M2. From M2, we called M3. Sir, I want to show this stack for you. Now, what is the output of this program, sir? Anyone, can you please tell me? What is the output?
5.
5.
5. 5. Now, let us execute. You can see 5 is the output. Sir, the code is not having any problem. Now, I am taking 10 by 0. Now, listen carefully. Sir, where the problem is came? In which method the problem is came? M3. Who called M3?
M2.
M2. Who called M2?
M1.
M1.
M1. Who called M1?
Main.
Main method. This is the point I am trying to explain in the stack, right? Now I will show you the proof. So the program is going to compile fine. If you run the program, you can see there is some runtime error came. Where the runtime error came? Sir, in M3 method. M3 method is created some problem. If M3 method is created some problem, who is the caller of M3? That we have to call that bloody person. So who called this M3? M2. M2, I am asking, M2, what is the problem? Sir, M2, I don't know anything because I called by M1. So M1 is responsible. Now who called M1? Main. In the main method, there is no handling. That's why we are getting some output. That is different story. Sir, you need to focus on these lines. So in which order these methods are called? So in which order they are entered into the stack frame? In that order only we are getting. The problem came here, next here, next here. Can I say this entire thing is the stack entry, right? This is nothing but a proof. Really, is the data is available in the stack or not? This is the proof. I hope everyone got some idea how methods are executing internally. Clear, friends? Not only in Java, in every programming language, this is the structure. Clear?
Yes.
Sir, everyone feeling comfortable? Good. Now, sir, I am giving the actual definition for recursion now. Listen carefully. See, next example. I am defining one method called M. Inside this, I am going to print system.out.println of something like sample method. Like this, I am going to print. So I am not calling any other methods, but unfortunately, inside this M, again I am going to call M. Like this we have. Sir, now what will happen? A stack, definitely stack is going to be created. First method is nothing but which one? Main, sir. So what is the second method? M. Sir, can you please tell me M is calling which method?
M.
M. Again, M is calling which method? M. It is calling again M. Sir, is it a continuous process or not?
Yes.
So, sir, this is a stack data structure. So, every programming language is going to give some memory for stack. For storing these method calls, they are going to give some stack. Up to that stack capacity, it will take all the method calls, no problem. Program will run. There is no issue with this. You can see. What is output we are getting? Sir, sample method, sample method, sample method. But there is some problem. Some at certain point, we got some issue. What is that issue, sir? I want to find out. Sir, have you observed? Here, exception is there in thread main. What is that exception? Java.lang.stack overflow. Whatever stack I allocated for you, up to certain limit I can handle. But it is going beyond the limit, I can't handle. Okay, corresponding entries are there in this particular packages. So who called these particular things? M method. First println creating a problem. So where it internally calls writeln. So these are nothing but various method calls what we have. I hope everyone understood what is mean by recursion. Sir, can I Can I define this recursion now? What is recursion? I can use a word like recursion. Recursion is a process of calling a method or a function by itself. Recursion is a process of calling a method or a function by itself. And the method which is invoked or involved in this process is called as what? Recursive method. The method which is involved in this process is called as what? Recursive method. But sir, I have a doubt. How you can stop this? Because it is keep on printing means not good, right? So how you can use these kind of algorithms in the problem solving? Yes, we have an option that I will explain in the next class. Sir, up to this, just I explained only 2 points. One is what is a stack, how internally method calls will be there. What is mean by recursion? Sir, seems to be it is a bit difficult topic, but there are n number of beautiful applications are there. Okay, I will explain all these applications in our demo classes. Sir, up to this, any doubt? So with this, I'm going to close the demo. If you are having any queries, you can feel free to ask. Tomorrow, we are going to see the problems related to this recursion. Any doubts, friends? Sir, clear everyone, please confirm. Sir, actual class started from today only. Okay, so actually in previous classes, batches, what I did is I'm taking some normal topic, any one random topic from the syllabus, and I'm going to take after that in the regular session again, I'm repeating. So, but seems to be that is not good wastage of time. That's why I'm starting a chapter. What is that chapter? Recursion. Recursion's chapter we started. So it will be continued. Okay, once completion of recursion chapter, then we will go with remaining. There is no dependency from one topic to another topic. Why? Because these are data structures, not programming language. Dependency is not required. Directly we can learn. Okay. Yeah, tomorrow as usual at 8:15. Okay, these 3 days demo sessions will be there as usual at 8:15. Once if the demos got completed, from Thursday onwards, maybe Thursday also demo, but maximum we will see up to Wednesday. So from Thursday onwards, we will combine with that 7:30 batch. Then you have to attend at 7:30. Whatever topics I covered for 7:30 p.m. batch, so I'm going to give backup for you people. Don't worry. Okay. I'm going to take live class for the topics. Any other questions? Where we will get recording. This video they are going to upload in the YouTube. First 3 days demo they will upload in the YouTube. Once if you register for this course by making the payment, so from that day onwards they will share the videos from day one. Okay. Any other questions? Right, friends, then thank you for attending the demo. Tomorrow we will meet for the continuation. Tomorrow, some types of recursions are there. I will demonstrate that and we will go with some programs. Okay. Right, guys. Thank you. Thank you for attending the demo. Have a nice day.
Thank you.